So here's a random question that leads somewhere both technical and artistic. What happens if you try to use a text editor to edit a JPEG? Well, depending on the editor you use and the edits you make, a variety of strange things can happen. If you use VI and type random characters in the middle of the file, the JPEG will most likely break in a really interesting way. This kind of intentional glitching of a JPEG file using a text editor is a form of data bending, which is the artistic misuse of a piece of software to edit files it wasn't intended to edit. The output that's produced is typically called glitch art, but you don't always get fun results. If you use Notepad to edit a JPEG, even if you don't make any changes and just select Save from the Edit menu, you permanently destroy the file and it most likely becomes corrupt and unreadable by image viewers. So this is somewhat confusing, and to better understand what is happening here, I've created an online glitch art editor that lets us peek inside of a JPEG file and safely make edits to a copy without destroying the original file. This app shows you the current state of the image, as well as the data inside of it. The various segments of a JPEG are color-coded, but I'll get into that more later. This table here on the left represents the bytes of the file. A byte is simply a fundamental unit of digital information and can be used to store one of 256 different values. So you can think of it as a number between 0 and 255, except here the number is represented in hex form, which is a base 16 numbering system that uses the digits 0 to 9 and the letters A to F. The table here on the right is the same information, just displayed as if the bytes were represented as ASCII text. It's similar to what you would see in a text editor. However, unprintable characters and values above standard ASCII are represented as dots, so it's a little different than what most text editors would display. But if you're editing this section, you can type over the data as if you were editing it in a text editor. When we look at the file produced after saving in Notepad, we can see that it made a handful of changes. Values that would have represented null and bell characters are changed to spaces, and values that would have acted as line-ending characters were normalized. It did this because it assumed the data it was dealing with was text, rather than binary data. These changes fried the underlying data too much, but if you're aware of the underlying structure of a JPEG, you can purposely glitch it to create something interesting. So at the byte level, a JPEG file can be looked at as a sequence of markers and segments. Think of it like YouTube video chapters. The markers are the timestamps and the segments are the information at those timestamps. A marker is just a 2-byte code that says, hey, this is what this section of the JPEG means, and a segment is just a block of data that contains specific data or metadata about the image. All JPEGs begin with a start of image marker. If that gets corrupted, the entire file becomes unreadable instantly, so it's best to leave that alone. After that typically come the application segments. These store optional metadata like JFIF info or EXIF camera data. You can corrupt them, but visually they're not very exciting. Usually nothing happens to the actual picture. Next, you typically see a quantization table segment. This is where things finally start to get interesting. Now, you don't want to mess with the first 5 bytes of this section. However, after that, you have the data for one or more quantization tables. Changing this data can totally fry the JPEG in a really interesting way. Quantization data controls how aggressively the image data is compressed. It's a set of 64 values that determine which visual details get preserved and which get thrown away. So when you mess with these values, you're scrambling the decoder's instructions for how to reconstruct the image. The decoder still works, but it uses completely wrong compression factors, creating blocky, colorful, and surreal glitching artifacts. After that is typically the frame header. This tells the decoder basic things like the image's dimensions and color components. Most of it is super delicate, but these 2 bytes that the editor highlights specify the width of the JPEG to the decoder, and changing them will cause the decoder to reconstruct the image with the wrong dimensions, which can lead to some pretty cool effects. Then you typically see Huffman tables, which contain encoding/decoding rules for the compressed image data. Messing with this data usually breaks the image, so this section is usually worth skipping, though in some images nuking the table completely can cause some pretty cool effects. Occasionally you'll see a JPEG with a restart interval segment. If a JPEG has these, your glitches tend to become more localized instead of cascading down through the image. JPEGs with these aren't really good for glitch art. And that leads us to the most important segment for glitching, the scan header. Now you don't want to touch the header itself, it's extremely fragile, but immediately after that is the compressed image data. This is the primordial soup where all the best glitches can originate from. Messing up the image data typically leads to the most interesting glitches, and errors usually cascade down through the image, so the best place to add glitches is right after the scan header. And as you can see, Glitches in the image data create all sorts of visual chaos, color shifts, blocky artifacts, horizontal displacement, and other strange effects depending on where exactly the image gets corrupted. One technical note to be aware of is that this section doesn't have a stated length, so you can accidentally define segments inside of it if you add an FF byte. This is the byte that all markers start with. If you need this byte for some reason, simply follow it with a 00 byte. This is called byte stuffing, and it's how JPEGs store FF bytes in the image data. If you see multiple scan headers, that usually means you've got a progressive JPEG. These store the image in multiple passes or frequency layers. Each scan gives you a different part of the image's reconstruction to play with, though there are non-progressive JPEGs that can contain multiple scan headers too. It depends on how the JPEG was encoded. But whatever the case, multiple scans typically mean more entry points to experiment with. So there you have it for a high-level overview of how JPEG corruption works. If you're interested in trying out this app on your own images, I'll leave a link in the description. I'll also leave a link to some interesting resources on glitch art in case you want to learn more about it. And to succinctly answer the question about what happens when you edit a JPEG with a text editor, well, chaos essentially. Unless you know what you're doing. Anyway, that's all I have for you today. Thank you for watching.